the computers or the device to do what comes naturally to humans and animals. So what we do, that means we learn from our experience. Okay, so if you have something being exposed before us, okay, beforehand, then a similar kind of situation arise. So if some question is been asked to us, then we are able to answer those questions in a much better way, and we take the decision in a right way, and we do decision making, we do critical thinking, reasoning, inferencing, okay, identification, recognition, several tasks, prediction, control, everything. So we do based on our own human intelligence. Okay, so when you put those things in a computer, and that becomes the computer becomes intelligence, and you say it is an intelligent system, and it will behave the same way. So machine learning is nothing but it's the machines and computers that these are some programs that are capable of problem solving and learning like a human brain. So the way we take the decision or intelligence thinking, the same thing the computer programs also perform. Okay, so it's a set of computer algorithms. So that makes the system or the computer to be the same way we human beings do. So that machine learning algorithms, some computational methods that learn from the information directly without relying in a predetermined model. So if you have the data and we have experienced something beforehand, then we from that experience we learn, and once we learn, then a similar kind of task is present. We take the decision in the right way, the right manner. That's the machine learning. So if you look at the machine learning category, so the types of machine learning algorithms, so we have broadly categorized into three types. One is the supervised learning, and another is unsupervised learning. Another is the reinforcement learning. Again, in the supervised learning, we have classification or regression, and in unsupervised, we have clustering, right? So in the supervised learning, so basically we have a supervisor or a guide which tell us, okay, so when you try to learn, so definitely in the first time we have some errors in the learning. So the guide is there, some supervisor is there, will continuously monitor and also make us learn exactly what is the structure or pattern present in the data. So that kind of learning is called supervised learning, and that is the task that we perform is the classification, regression, identification tasks. In unsupervised learning, we don't have any guide or supervisor. We just have the input data. We just present the input pattern, input data. Then we try to segregate those data, looking at the similarities or dissimilarity present in the data itself. So you try to segregate and put in one group. Okay, so that's is nothing but is the clustering task or unsupervised task. Similarly, in the reinforcement learning, so we have a set of actions. Okay, we set of tasks that we do, and every task leads to a leads to a satisfactory performance or unsatisfactory performance. Based on that, we have some reward or penalty in the tasks that we perform. Then you need to sequence. You need to follow a sequence of tasks. Okay, in such way that that leads to success achieving the goal. Okay, so finding out that sequence of tasks which leads to less penalty or or the higher credit score, so that leads to the goal. Okay, so that is called, that kind of learning is called reinforcement learning. So basically we do in the game playing. Okay, game playing and robotics navigation, robotic pathfinding. So those kind of applications basically we do the reinforcement learning. So if I go a little bit more depth into the supervised learning as a classification task, so here we have a set of data, and the data have some label. Okay, so if I have here, so three different class or the different type of objects are here. One is triangular, another is square, another is hexagon structure, right? So there is three different labels associated with it. So the triangular one we can have is the class 1 or class level level 1, then rectangular one level 2, and the hexagon one level 3, right? Then we present this data along with the labels. to the training of the model or the device, right? Once the device is trained, so that means it learn what are the different structures present in the different types of class, right? Then whenever a new sample test data is being presented, so it will predict exactly whether it's a square class or is the triangular class. So it does nothing but it try to find out what is the internal structure or the pattern present in the data, so that whenever next time similar kind of data is being presented, it will predict in or classify or it label in a correct way. Okay, so here the labels are the guide or the supervisor which supervise the learning of the model in a perfect way. Okay, so this is a classification task. So we have certain labels and we try to predict the class level from the unknown data, right? So we have typical examples or problems. So basically image classification, we try to classify the image of what type, okay? And if is there any specific object present in the image. Okay, so disease prediction, whether it's a the sample is a cancerous disease or non-cancerous data. Okay, protein localization and function prediction, the interaction predictions. Okay, several kind of classification tasks we perform. Similarly, if you look at the regression, this is another type of supervised learning. So here we don't have the labels. Okay, we don't have the labels associated with the data. It is the continuous, value. Okay, it is a continuous form, and there is no discrete label. So it is a large label. So I can say large number of labels associated with each data point, and you try to fit a particular curve into the distribution of the data points. Okay, for example, if I fit here a straight line as the underlying pattern present in those data, okay, so then we can extrapolate the beyond this point, we can extrapolate the pattern and we can make a predict or forecasting of the tax at our hand. Okay, so that is called your regression. So we are regressing the pattern, or you are trying to identify the pattern or the structure present in data by a curve fitting applications. Okay, so we have a demand forecasting, retails, sales prediction, oil price prediction, right? Real estate price prediction, weather forecasting, drug target prediction. Okay, so this kind of application or recommendation system, movie recommendation system, right? Those kind of applications we can form in the regression category. Similarly, we have clustering, as I said in the clustering tag. So this is a part of unsupervised learning. So here we don't have the labels associated with the data. Okay, so there is no supervisor, only the data point we have, and looking at the similarity, dissimilarity of the data points. So we try to group them into a particular cluster. Okay, so if you look at this data can be grouped into one, just like the black star data points, and then the red one is another class, and the pink one is another class, right? So here we don't have any label associated with this. Only you try to find out the similarity between those data points, and based on that, who are similar, they will group them one class or one cluster, and you group them another cluster, right? So this is called your clustering application. Some applications are image segmentation, like in the image, what are the objects are there, we segregate or we classify those objects as different groups. Okay, and then microarray data analysis, also we have a large amount of data coming out in the biological experiments, and looking at the data itself, so we can have some clustering, so that leads to a little bit more insight towards the disease causing mechanism or some biological process happening in our body. Okay, then sensor localization in sensor networks. So we place the sensor in a particular area. So looking at their data pattern or the energy distribution pattern. So now we can make it one cluster, several clusters, and we can management the energy in a much efficient manner uh, for a specific applications. Okay, so this is some examples of clustering. So here we don't have any supervisor which tells to label predict the labels. Okay, so only we have the data, and based on the data pattern itself, we are trying to segregate into different clusters. Okay, so these are some of the concepts of machine learning algorithms. But if you look at, there are several dozens of machine learning algorithms, both supervised and unsupervised type. Okay, if you look at the classification, we have support vector machine, discriminant analysis, naive Bayes, nearest neighbor. Okay, in regression, we have linear regression, support vector regression, example methods, decision tree. Similarly, we have clustering application, k-means, k-medoid, hierarchical clustering, Gaussian mixers, neural network. So several versions of machine learning algorithms available, but which one is best fit for you? So choosing the best one is the balancing act. Okay, so there is no method or one size fits to all. Okay, it depends on the machine learning algorithm selection. It depends on the size and the type of data you are working with, and what kind of inference or what kind of insight that you want to get out of the data. Okay, so that will help you to choose which type of machine learning algorithm that you want to apply, and which one is will be best fit for your the data that you have. Okay, so choosing the right algorithm is a misnomer. Okay, it is a balancing act. Okay, so it depends on the type of data or the type of insight that you want to draw. Okay, so blindly applying machine learning algorithms will not solve your problem. Okay, so rather than, we need to go for a systematic approach by looking at the data point, the data set you have, and what type of things that you want to draw. All right. So this is the, I can say, the dogma of machine learning algorithms. So if you have more data, more queries, then better your answer. Okay. So the more number of data points you have, and more questions you ask, okay, so that will learn better. The model will learn better, and it will answer in a better way whenever algorithm is present before the unknown set of data points, right? So that means the machine learning algorithms find natural patterns or structures in the data that generate an insight and that help you make better decision and predictions or forecasting. Okay, we call this the dogma of machine learning. Okay, so the more the data, more the query, the better will be your inference or your decision making. Right. So these are some of the concepts in the machine learning. So it depends on what type of data set you have and what type of tasks at your hand and what inference or what insight you want to draw from the data. Based on that, you need to choose those algorithms. Okay. So we basically apply machine learning in several healthcare applications. So I'll be discussing here one application of healthcare technology. Okay, so before that, how basically the machine learning model works basically. So we have a set of data points here, and we split the data into a training and testing part, and then you use this training data to develop the model, the machine learning model. Okay, which is basically map the input to the output. We try to find out some mapping of the input data to the output that we have. Okay, once this mapping is done, so that means we found out what is the underlying pattern present in the data, and what is the structure present in the data. Then once it is done, then we test those test data, whether it is going to predict the same class level, or the you try to segregate in a particular manner or not. Okay, so once it is validated, now we say our model is ready, then we can expose our model for a prediction to a new data point, right? So this is the machine learning flow graph that basically we use, right? So the input could be a sequence of features, right? The output could be interacting, non-interacting type, yes or no questions, right? Okay, class 1 or class 2 or class 3, like that only. And in the training, you try to build a classifier or clustering technique, and that try to find out the mapping between input and output. Okay, so that means you try to find out the pattern present in the data. Okay, so the key idea is learn from the known data set, and then generalize to unknown data points, right? Or to make prediction or identification for the unknown data, right? So it is learning first, then it go on applying in the unknown data sets. Okay, so let us look at how we can apply in the healthcare application. Okay, so I'll be discussing a little bit on how the machine learning being used in Parkinson disease prediction. So Parkinson disease, one of the most prevalent disease in the old age. So basically, the Parkinson disease, what happens? It is a neurological degenerative disorder in the central nervous system, okay, which caused by the loss of a neurotransmitter, which is called dopamine. Okay, so if the dopamine neurotransmitters are not getting deposited at substantia nigra in a proper amount, okay, so that leads to a Parkinson disease. And what happens in the Parkinson disease, if it happens, then there will be a dysfunction of motor. Okay, so the motor organs in our body, it try malfunctioning, so we cannot walk properly, stand in a particular manner. Okay, if something if the shaking of hand is happening, so it will go on continuously doing like that. So that leads to a miserable life. Okay, so around 10 million people around the world is suffering from Parkinson disease, and mostly it has seen that it happens in old age, more prominent in above the age of 60, and sometimes it also happens in the early age of 40 or 45, like that. And it is such kind of disease. Once it happens, so there is no cure, no drug available to cure the disease, right? So you have to live with a miserable life forever. So is it there is any kind of technique that can available to predict the Parkinson disease in early stage? Okay, so that's the question. So can we identify the pattern in the Parkinson and non-Parkinson, right? And then we can predict it early stage so that we can prevent the onset of the Parkinson disease, you know, uh, quite early, so that we can delay the onset of that. Okay, so if you look at the symptoms, basically, as I said, there is a rigidity and postural instability. We cannot stand still for a long time. Okay, so there is a tremor, shaking of hand, shaking of leg, like that only. So gait impairment, so gait difficulty, you cannot walk properly. Okay, so problem in handwriting. Okay, and you cannot speak also in a proper way. So vocal dysphonia also happens. Okay, and that leads to also joint pain. Okay, mental behavior issues also, loss of smell. So these are some of the symptoms that happens when Parkinson disease is prevalent. And mostly the confirmation state is the gait impairment and postural instability and tremors, right? So once it happens, once someone go into this stage, then Parkinson disease will confirm, and you have to live with forever with this particular dysfunction. Okay, so what are the different diagnostic methods that is nowadays available for Parkinson disease identification? It is nothing but the imaging techniques like the magnetic resonance imaging (MRI) and the SPECT imaging, which is very costly, and expert has to be there to examine whether someone is going to Parkinson disease or not. Then olfactory probes, loss of smell, and rapid eye movement disorder, sleep disorders also happen. So some test has been performed to confirm whether someone is having Parkinson's disease or not. Then gait impairment, as I said, the movement instability, the problem in movement, that is leads to a gait impairment, and the speech impairment also, as I said, the speech also deteriorates. Okay, so these techniques, the MRI techniques and REM, RBT techniques, these are, and gait impairment testing. So these are highly costly, and expert doctor has to be there to evaluate the Parkinson disease onset. Okay, so can we devise any methodology which will give an indication in a non-invasive way for the early onset of the Parkinson disease. Yes, so there is a process we can assess or examine the onset of Parkinson disease using the speech evaluation, right? The speech impairment, and it has been seen that the Parkinson disease people who are suffering from Parkinson disease, around 70 to 90%, they have a speech disorder. So they can't speak in a proper way, and some dysphonia or some disorder happens in the speaking, because the muscles associated with the speech production that is getting deteriorated because of the loss of dopamine, and the speech related motors, they start malfunctioning, then we can't speak in a much better way. Okay, so that is the indicator of the onset of Parkinson disease, and 75 to 90% of the patients, they have a speech impairment. Okay, so now speech is easily acquired and easy process, non-invasive method, so we can utilize the speech as indicator for onset of Parkinson disease. Okay, so we can classify, we can predict whether a speech, a recording speech, is of Parkinson type or a healthy one. Okay, so that's the thing that we need to identify using the machine learning algorithm. Okay, so if you look at the spectrogram of speech of healthier Parkinson people, the left one is the speech of a Parkinson people, and the right one, they have asked to speak the vowel A, and vowel O also, right? So here it is being shown only the result of vowel A. If you look at in the time domain, the speech pattern is not visible that much, but if you look at the spectrogram, the energy is getting spread over the frequency, but whereas in the healthy one, so there is no spread of no leakage of energy in the spectral domain, in the frequency domain, right? So this is an indication that there is a differentiation in the speech production system, the way we speak or pronounce the words, the vowels, or the sentence. That is not the same way the Parkinson people they speak, right? So this is an indicator. So we can capture this behavior or this pattern, then we can design a machine learning algorithm, and that will predict if a speech sample is being presented with the device, you can predict whether it is of Parkinson type or healthy type, right? Okay, so what is the effect of Parkinson disease on the speech production system? So our is nothing but the interaction of our vocal fold and vocal tract. Okay, vocal fold is a small tiny muscle present in the epiglottis area in our throat. Okay, so which is produced some fundamental frequency of small sound, sound elements, and then sound, when it is filtered by the articulatory organs in our mouth cavity, such as the jaw, the lip, the tongue. Okay, then the sound is getting modulated, and we hear in a different sounds, right? So it is the interaction between the vocal fold and vocal tract, and that is getting deteriorated when a Parkinson disease affects. Okay, so the Parkinson disease exhibit an incomplete vocal fold closure and increased breathiness during the phonation. Okay, so that means we'll quietly notice some different pattern of vocal fold vibration. Okay, so that leads to the identification of Parkinson disease, right? So most of the algorithms, they focus on analysis of the vocal fold related problems that is related to the fundamental frequency, and the working of the vocal tract, that is the nose, mouth, tongue, lips. Actually, also they creates different steps to the sound, and that also getting deteriorated whenever Parkinson disease acts. Okay, those are called your format frequencies. Okay, so the fundamental frequency and format frequency. Okay, so these two are the parameters that actually differs from a healthy person to a Parkinson's disease person, right? So we can capture those things, those differentiation in the speech signal to identify whether it is a healthy one or is a Parkinson disease one. Okay, so the detection process will have a data acquisition system with a microphone. We'll have the recording of the speech for certain duration. Then we can extract the features, okay, and select the features of the speech signal, because we can't input these things directly. Okay, so it has to extract those features that actually related to the malfunctioning of the speech in the Parkinson disease, right? Then we will model a classifier which will classify whether it is a healthy one or it is a Parkinson disease speech, right? Okay, so this is the entire process. Now let us look at what are the feature extraction of this speech signal. So there are several features being used for Parkinson disease identification. One of the baseline features are acoustic features. It depends on the variation in the frequency or the variation in the amplitude of the speech signal, and the harmonic parameters, harmonic to noise parameters, the pitch parameters like the median pitch, mean pitch, the standard deviation of the pitch, then some voicing parameters, some pulse parameters. They all together forms the acoustic features, right? These acoustic features is the indication of how the variation of the speech in amplitude as well as in the frequency direction, right? Okay, so people have used these acoustic features as an input to the machine learning model, and the model try to find out whether it is a Parkinson type or healthy one. Similarly, we have frequency domain features like the male frequency substral coefficient, MFCC, then LPC, linear prediction coefficients, okay, linear prediction substral coefficients in the frequency domain. And if you look at the MFCC features, this is most widely used feature to represent the speech in various applications. So here we have input speech, then we do some kind of filtering or pre-processing tasks, then windowing, then find out the frequency, taking the FFT, fast Fourier transform, then use the male filter bank over this, then we apply the DCT, discrete cosine transform, that leads to the MFCC feature. So it captures what are the variation in the vocal tract, okay, the vocal tract variation in the terms of form and frequency. What is the change in the form and frequency of a speaker? It happens. So okay, so this capture actually the MFCC features. Similarly, in the LPC and LPCC, so it will be the same procedure. So after windowing the speech signal, so we have autocorrelation analysis, then we do the modeling like the linear prediction coding. Okay, so the linear prediction coefficients will be taken in the spectral domain, that leads to LPCC features. Okay, and this LPCC feature also, it is a characteristics of the speaker in the sense that it represents the vocal tract information, the form and frequency information, right? Okay, so these are the methods available people have used for discriminating the healthy speech from the Parkinson disease speech. Okay, the problem here is, if you look at the spread of the data point, okay, it looks like in the MFCC feature domain. So if 0 is the healthy one, and the 1 that is the red one, it is the PD class. Okay, so there is two class, healthy and PD, Parkinson disease. So if you look at the distribution of the data points in the MFCC features, so they are very correlated and they are overlapping each other. So designing a hyperplane or learning the machine, what is the pattern present in the data, it is a little bit difficult to learn the pattern, because they are mostly overlapping to each other. So we cannot discriminate those points, right? Okay, so then people started looking at what are the other features that we can extract from the speech signal that will help us to discriminate those samples in that particular feature domain, right? So for that, if you look at the acoustic features and MFCC features, there are two important limitations. One is firstly, the features are either related to vocal fold, that means the fundamental frequency, or the vocal tract information, the form and frequency information. They can't collect both of the information simultaneously, right? So because of that, they are the limitation. The prediction task by the machine learning is limited. Secondly, the nonlinearity. The speech signal is a nonlinear signal, so it can capture the nonlinearity in an efficient way. Okay. So then we have actually proposed some new techniques which will capture both of the information simultaneously. How this fundamental frequency and format frequency, they vary in the Parkinson disease speech, right? So for that, we try to implement another method called empirical mode decomposition. So it is EMD. It is nothing but nonlinear, non-stationary uh, data representation method, which actually decompose the non-stationary signal into in a form of M and FM oscillations, and creates a intrinsic mode function. Okay, so that intrinsic mode are nothing but is the representation of the data or different oscillation pattern present in the data, right? Okay, so if you look at its applicability, so if this is one a synthetic data. Okay, so it is a waveform of low and high frequency, composed of low and high frequency. Okay, so let us look at what are the intrinsic modes, or what are the the oscillations present in the data sample itself. So we'll apply the EMD. First, we'll look at the variation in the maxima, local maxima and local minima. Okay, so in the input signal. So if you look at the red dots are represents the maxima. Okay, the maximum point in the variation in the data. Okay, in the waveform, and the blue one is the minima. Okay, so now we join line. If you join this red dots, that will form a wave like structure like this. And if you join the blue dots, that will form another waveform. Okay, just like this. Now you take the average of this, the mean of that. Okay, so then we extract the mean, okay, from this signal, that will leads oscillation pattern. So this is nothing but we call the intrinsic mode. Okay, so this is one intrinsic mode. So this oscillation pattern present in this non-stationary signal. Okay, then you use this IMF1, and will go on decomposing in the similar fashion, that leads to another mode. Okay, another oscillation pattern present in the signal, right? Okay, so this is IMF2, this is IMF1. So this one is representation of one type of oscillation pattern present in data, and this is represent another oscillation pattern present in the data. So these are the characteristics of the variation of the format frequency and the fundamental frequency. Okay, that these are captured in an efficient manner. Right. So if you look at the significance of these IMFs in determining the vocal fold and vocal tract information. So for to demonstrate this, we have synthesized a voice signal having a fundamental frequency of 100 Hz and format frequency of 700, 1400, 2800, and 3500. Okay, so this is the spectral of the input signal, right? Now, if I decompose the speech signal into different IMFs, so if you look at IMF1, the black one, it captures the format frequency. So this one, the 700 format frequency, then 1400, and then 2800 and 3500. So it captures the format frequency very efficiently. Then IMF2, it also captures some of the format frequencies. IMF3 also captures some of the format frequency, like that only. And if you look at the green one, the IMF5, okay, so it captures the fundamental frequency. Somehow it captures the fundamental frequency here. The peak shows around 100 Hertz. It shows that it captures the fundamental frequency. So that means the variation in the frequency, the vocal fold as well as the vocal tract, both frequency information captures in different IMFs. Okay, so then the energy content in these different IMFs will gives us an indication whether the speech signal is of Parkinson type or healthy type, right? So if you look at the energy of the different IMFs, the energy pattern looks like this. So this one is a speech tax of A, vowel A, the speech, the variation in the energy. And this one is the energy of Parkinson disease of the same vowel tax A. Okay, if you look at the clear distinction in the energy of the speech of Parkinson people as well as in the normal people. Okay, so so this one is gives an indication how the energy is varying. Okay, how the energy deviation in both types of speech. So this help us to run this pattern. Okay, to design machine learning algorithms to capture this pattern. Okay, similarly we have entropy variations. So variation in the speech, in the normal speech, and in the Parkinson speech there is a quite variation. There is no entropy variation in the normal speech, but there is a variation after IMF number 5 in the Parkinson speech, right? So we devise another feature, okay, new feature called intrinsic mode of frequency subtle coefficient. And then again we followed the same path here. So speech signal, we decompose the signal using EMD into different IMFs, take the log energy of these individual IMFs from the DCC, discrete cosine transform, and that leads to the subtle coefficient. So this subtle coefficient captures both Fermat frequency and fundamental frequency most efficiently or simultaneously. If you look at the pattern, it looks the pattern like this. The speech of normal people and the speech of Parkinson in the tags of A and O, right? So there is a clear distinction between the pattern present in the MFCC coefficients. So if you look at the distribution of the samples in the IMFCC feature space, it is a little bit more better than the only the MFCC features. Here it is a little bit distinction between the blue points from the red points, right? Okay, so we can design or we can learn the structure is a much better way rather than the MFCC feature. Okay, so this gives an confidence for applying our machine learning algorithms to learn a better way the pattern present in the data. Okay, so what we did, so we take some the data points of Parkinson, 50 Parkinson people and 50 subjects from the normal. Okay, and we try to form a support vector machine to discriminate between these two types of samples, of Parkinson sample and the healthy samples, right? What a support vector machine does basically, so we have two class, right? Class one of, if you look at the red samples here, and the blue one is the class -1 or the other class.
I think your video is your PPT is not visible. I think there are a lot of participants who are raising their hand.
Okay.
Let me unmute them first of all.
Is it
Yes,
not
sir,
visible
your
now?
slides are not visible. We are not able to see the slides.
Oh, so let me. Should I present again or what? Where I missed? Actually, I don't know.
Sir, it's not
let
visible, sir.
Okay.
okay. So, let
We are
me
trying
present
to
again.
rectify it.
So just after acoustic features.
Can you see the slide now?
It is
Yes, sir.
visible,
Yes,
sir.
sir. Thank you, sir.
Okay. And where I left actually, where you missed
Just
the
after
slide.
acoustic features.
Yeah, from the slide, sir.
Okay, so this one,
Yeah, sir.
this one.
Yes, sir. After that.
This one, sir.
Okay.
This one, yeah.
All right. So this is one type of picture extraction procedure, the MFCC and the LPC features. The LPCC features basically. This is widely used, feature extraction process. Okay. So here, what we do basically, we take the speech signal, then we do the reprocessing and windowing, then take the FFT, and then pass through a mail filter bank, and then the signals from the mail filter bank pass through the discrete cosine transform, then it forms MFCC picture. Okay, similarly the LPC1 is after the windowing, so we do that autocorrelation analysis, then take the linear prediction coefficients and use that coefficients in the substral domain, that becomes LPCC feature. So these features actually calculate the vocal tract information, right? The frequency information only generated by the vocal tract. Okay, so if you look at the distribution of the features in the MFCC domain, so if you look at, there is overlapping of the feature. Is it? Can someone tell me, is it visible clearly or not? The slide is visible.
Yeah.
Yes, sir. Yes,
Okay,
sir.
all right. All right. So if you look at, there is a complete overlap of the samples, the distribution of the samples from the PD and from the healthy. So blue one is the healthy one, and the red one is the PD, Parkinson disease. So MFCC feature is not that much discriminative to learn the pattern present in the data set, because it is overlapping. So it may happen that there is a misclassification of the class level. It happens. Okay. So what we do basically, so we try to find out a way that will capture both these information. Okay, the energy variation of the speech, that means in the format frequency and the fundamental frequency. For that, we try to devise a method called empirical mode decomposition. Okay, the empirical mode decomposition, basically we try to decompose the signal, non-stationary signal, into different intrinsic modes. Okay, the intrinsic modes are nothing but the underlying pattern or underlying fluctuation present in the signal itself. We can say this is one oscillatory pattern present in the signal. So if you look at the procedure, first we try to identify the local extrema. Okay, the minima and the maxima. Okay, so the maximum points in the signal will be joined, that will form a signal, and the minima points, the blue one, if you join, that becomes another envelope, and these two envelope you average and take out that average from the input signal. The rest one is nothing but will give you this IMF1. Okay, so this IMF is, if you see, this is some oscillatory pattern present in the signal, which is which is underlying structure of this input signal itself, right? Similarly, if you use IMF1, the same way find another oscillatory pattern, which is also an inbuilt or hidden structure of the signal variation. Okay, so these IMFs actually try to capture what are the format frequency and fundamental frequency information. So if you look at here, we have a synthesized speech signal having fundamental frequency of 100 Hertz and 4 format frequency, and the spectral pattern looks like this. Okay, so if you decompose the signal into different IMFs, you see the IMF1, the black one, contains 4 format frequency. One is here at 700, 1400, 2000, and 3500 frequency. Right? Then IMF2 also captures some of the format frequency. Okay, so the higher IMFs captures the fundamental frequency. If you see the blue one, the IMF5, sorry, the green one, the IMF5, it captures the fundamental frequency. So it gives us in a way to capture what are the different frequency pattern present in the speech signal, right? So now if I take this one as a feature domain by looking at the energy, okay, in the particular IMFs, the energy variation happens in this way. So there is no change in the Parkinson speech and in the normal speech. Okay, if you see, the energy variation is quite different, the normal speech and the Parkinson one, right? Okay, so right side is the Parkinson one and left side is the normal one, right? So similarly, if you look at the entropy variation, is a quite clear pattern in the normal entropy and the Parkinson speech entropy. Okay, so then using these IMFs, we devise another feature which is called intrinsic mode function substral coefficient, and this is a flow graph. We first divide the signal into different intrinsic modes and take the log energy of these IMFs, then take the discrete cosine transform that forms a new feature called IMFCC. And if you look at the energy of the different coefficients, IMFCC coefficients, so again there is a clear pattern in the variation of the Parkinson as well as in the healthy speech. Okay, so if you look at in the MHCC feature domain, the distribution of the data point. Okay, so if you see there is a clear distinction of the red data points, that is the PD samples from the healthy one. Okay, so now our model can able to grasp what is the pattern, what is the underlying structure present in the data point itself, so that it will clearly distinguish between the PD from the healthy one, right? So IMFCC feature domain is a little bit more discriminative rather than the only the MFCC or acoustic features, right? So we have used the support vector machine as a machine learning model to find out a discriminating line between these two type of class. Okay, so what is support vector machine? So it is nothing but if you see it, try to find out a differentiating hyperplane or separating hyperplane between the samples so that it will clearly classify above of this hyperplane is class 1 and below this hyperplane is class 2 or the class -1. Okay, well, how it does, if you see there is two classes, the red circle is class 1 and the blue circle is class 2. Okay, so we try to find out what is the closest points from the separating plane or the straight line, right? Okay, so the closest points are the support vectors, and the distance of the line from the support vector, if you might take the margin. Okay, so this one is the margin of class, the closest point of class 1, and this is the margin of the distance of the closest point of class 2 or class -1 from the separating plane. Okay, so then this the margin of these 2 points. Okay, if you try to maximize the margin between these 2 points, and then that will be the best separating plane or the best hyperplane or the straight line that will distinguish between the class 1 and class -1 in a proper way. Okay, so this is the optimization problem of maximizing the margin between the support vector or the closest point of the two class, okay, from the straight line. Okay, so we try to finding out the maximum margin by solving this distance as a objective function. Once we find this straight line, then I can say that above the straight line is class 1, below the straight line is class -1. Okay, so this is the support vector machine. This is one a type of machine learning algorithms, and this is a classifier. Yes, please. Yes, any query?
Any query? No, I think it's not.
Okay.
We will ask the question, we will take the question at last, okay?
All
Please
right,
continue,
okay.
sir.
Yeah, I'll take another 5 to 10 minutes to complete. Okay. So, okay, so if you look at the classification results, the IMFCC features, it gives me a classification accuracy of 76% in the tax of vowel A. Okay, in the tax of vowel E, so it is giving 75% of accuracy. That means discriminating between the PD and the samples. Similarly, others samples with the IMFCC features are more better than the regular MFCC and acoustic features. Okay, it is because of its discriminating capability. Okay, in the input of feature space, right? So if you look at in the words, okay, so similar speakers have been asked to utter the word ghetto, acto, reina, blusa, like this. So if you look at these speech samples of this utterance, this word, okay, so these IMFCC features are giving better accuracy than the normal or standard MFCC and acoustic features. Okay, so Gato it giving me 70% accuracy, then Reina giving me 77, like that only. So then to find out another feature which is called Hilbert spectrum in the energy distribution in the Hilbert spectrum. So this is basically time frequency representation scheme. So here we try to see the pattern of the Parkinson disease speech energy distribution and the healthy one. You'll see the energy is getting deteriorated in the frequency domain, and then if you could capture this variation in the Hilbert spectral domain, we can devise a new feature that will be more discriminative, means dividing the class of Parkinson speech and the normal speech. Okay, so here we find out another feature called IEDCC, so instantaneous energy deviation substral coefficients. So it is the process is like this: the speech signal will be decomposed using EMD, empirical mode decomposition, into several IMFs. Then take the Hilbert transform of each IMF. Then find out the instantaneous energy and the instantaneous frequency present in each IMF, right? And then take into a logarithmic scale and then apply the DCT that leads to instantaneous energy deviation substral coefficient IEDCC. Okay, so now if you look at the same samples when I plot in the IDCC feature domain, so it is quietly discriminative. Okay, so the blue one is clustered in this one side and the red one is clustered in other side. So now my support vector machine will try to devise a separating hyperplane or this straight line between these two groups, okay, by maximizing the margin between here to here and here to here, okay, and this will give me a much better classification accuracy. Okay, so look at the experiments, the results. The IDCC feature it gives me 82% accuracy in the same speech tags of vowel A, okay, which is better than IMFCC and again better than the normal IMFCC features. And similar pattern observed in all the vowels E, I, O, and U, right? Similarly, if you look at the percentage of improvement, around 5 to 25% improvement in accuracy, we observed in the instantaneous energy deviation substral coefficient feature. Similarly, in the word, if you look at in the word also, we are getting the higher accuracy using the IDCC features, which gives me around 90% accuracy in the word apto, right? Similarly, in the RENA, we are getting 81% accuracy, which is quite better than the IMFCC and MFCC and acoustic features, right? So if you look at the improvement in the accuracy using compared to the baseline features in the acoustic and MFCC, so which was giving me around 40 to 80% accuracy in different speech tags. Now it is increased to 70 to 85% in IMFCC feature, which is based on the only the energy deviation of the intrinsic mode function. Okay, now if I take in the Hilbert spectral domain and find out the deviation of energy there in the Hilbert spectral domain, so we are getting the accuracy increase up to 80 to 93% in different speech tags. Okay, you see there is a quite jump in the accuracy uh, in the discriminating capability of the support vector machine in different features, right? So it is very important to capture the relevant information from the data, okay, so which gives you better discriminating capability the features, then your machine learning models will be better in prediction of those samples, right? And this is a detection system, so overall detection system as I discussed earlier. Okay, so yeah, these are few of my publication in the same area. So if anyone interested can look on those papers to get more details how machine learning is being used in identifying or finding out the prediction of the Parkinson disease. Okay, so that's it from my side. If anyone having any query or questions, you can ask me. I will be happy to answer your questions. Thank you.
Participant, do you have any queries? Participant, you can unmute now.
Put your
You can-
questions in the chat box.
You can unmute yourself and ask any query if you have. Participants, have you any query?
Good afternoon, sir.
Good afternoon.
Sir, I am a mathematics student. Sir, I am in a new from machine
Okay.
learning. I have a one question, sir.
Okay,
Sir,
please.
sir, how we visualize the data?
The data is actually the speech. The data is a speech signal, and we cannot directly plot the speech signal to look at the variation present in the PD and the healthy one. Then what you do, try to extract or represent the speech signal in different domain. Okay, which is called a feature extraction. So we extract different features like the acoustic features. So how the signal is getting varied, and what are the frequency variation. Okay, so then we extract the features, and in the feature domain itself we see the distribution of the PD samples as well as the healthy one. Okay, so that is the representation scheme of the data, and we see that for various feature, the distribution of the samples in that feature domain is discriminative. If you go on extracting the feature from MFCC to IMFCC to then IEDCC. Okay, so that help us to improve the accuracy in the machine learning, the support vector machine. Yeah, I hope I have cleared your doubt.
Any more queries?
Thank you, sir.
Any more queries? Participants? Am I audible, sir?
Sir, can you explain overfitting?
Yeah, overfitting is quite obvious in the machine learning domain. Basically, if you have design your algorithm which is not actually generalized to the distribution of the samples. Okay, rather than looking at or finding out the general pattern present in data, if you try to memorize. Okay, if you try to memorize what is the class level of the data samples, then it leads to the overfitting, or in the sense that whenever you try to test with a new sample, then it will completely fail to predict properly the class level, the class class type. So that's called your overfitting. It generally happens if you have a large number of training samples that you try to train, or if in your model the parameters that to be trained, okay, or that is to be optimized, if the parameters are more compared to the samples, then in that time also your model goes to overfitting. Okay.
Okay, sir.
So
Thank you, sir. Thank
it
you,
is.
sir.
Any more? Participant? If you have any query, you can mail to me also. I will forward the mail to Sahu sir. Okay. Okay.
Yeah, if anyone having any query, you can put an email to me also. I'll answer your questions.
Okay. So now let me propose a lot of thanks to Dr. Sitanshu Sekhar Sahu, sir. So it's my privilege and feel honored to propose a lot of thanks to Dr. Sitanshu Sekhar Sahu from the Department of Electronic and Communication Engineering, Birla Institute of Technology, Mr. Ranchi. So your lecture on machine learning in healthcare was very good. It's a very brainstorming lecture. You have discussed a lot of things about machine learning, the type of machine learning, for example, supervised, unsupervised, reinforcement, what is classification, regressions, clustering, and you have discussed the machine learning model also, and what are the symptoms of different diseases and how to tackle them, and what is acoustic features, and the spectrum we have discussed, IMF spectrum we have also discussed. We have discussed support vector machine and Hilbert spectrum you have also discussed, sir. Really, it was a very good and very elaborative and brainstorming lecture, sir. It's our honor to have you among us, sir. Thank you so much, sir, for giving your valuable time to our participants, sir. We feel honored, sir. And please send your PPT so that we can circulate our participants. Thank you, sir. Thank you so much, and have a nice day, sir. And we also wish that we will meet again in a coming workshop, sir. We also are organizing some workshops
Yes.
regularly, so
Sure,
we will
sure.
definitely contact to you, sir. Thank you, sir.
Yes, sure.
And I will send
Sure.
a
Thank you for having
honorarium.
me. Your FPP.
Okay, I will send you a honorarium receipt, sir. Please sign it and send to me, sir. Thank you, sir.
Yes, sure. Okay.
Thank you, thank you. You
Okay.
may end
Thank
your
you.
meeting, sir. Thank you, sir.
It's a
Okay.
pleasure.
Thank you,
Yeah.
sir. Please end your meeting, sir.
Yeah.
Dear participants, am I audible to all?
Yes.
Okay. So we have we have the next lecture at 2:50. Okay. So we will meet at after 5 minutes. Okay.
Okay, sir. Thank you.
Okay. Please, Anna, join the session. Okay. No need to left the meeting. Okay.
Okay, sir. Sure.
Yes, sir.
Okay. Please continue with this session. Okay. And please fill the attendance. I have sent you the attendance. Participants, I have sent you the attendance of the evening session. Okay. Please mark your attendance as it is a compulsory. We have to, you have to have at least 80% attendance to have the certificate from IGNT Amarkantak. As you know, it's a central university and attendance is very critical over there. Attendance is mandatory. And every day I will send the feedback form at 3:30 also. So you have to send the feedback form regularly. Okay, for all the resources person. Okay, if somebody have any query, you can mail to me, you can WhatsApp to me also, you can text on Telegram also or Facebook, whatever you have the medium. Okay, you can send to me the text. Okay.
Okay, sir.
Okay, sir.
Ruby ma'am, are you able to listen? Ruby ma'am, you can contact to me. Ruby ma'am, are you there?
Yes, sir. Yeah.
Okay, please tell me.
Yes, sir. So the feedback form that will be open till like only 30 minutes are given to us or
No. Feedback form will be opened
Yeah.
till night at 10 p.m. Okay.
Okay, sir. Thank you so much.
Okay, you just text to me. Okay, I will do something for the yesterday session also. Okay.
Thank you, sir. Thank you so much.
Okay. Good afternoon to one and all over there. Dr. Vijay, are you there? Dr. Vijay?
Yes, sir. Yeah, I'm yes. Yeah.
Okay, dear participants, today's session resource person has joined. Now we have among us Dr. Vijay Bhaskar Senwal. He's working as an assistant professor in a department of computer science and engineering in MNIT Bhopal, and he's a very prominent and eminent resource person in the field of machine learning. And if we're talking about his qualification, he has done his BTech from the College of Engineering Roorkee, his MTech from IIIT Allahabad, and PhD from the IIIT Allahabad also. And if he has the different kind of experience, he has the experience of the software companies also, and he have the experience the academics also. He has worked software engineer, senior software engineer in different companies, and he has worked in a different grade in NIT Jamshedpur, IIIT Dharwad, NIT Rourkela, and presently he's working as a senior assistant professor in MNIT Bhopal. Sir, it is our privilege and honor to have you again among us also, sir. Thank you so much for giving your valuable time, sir. Over to you, sir.
Okay. Thank you, sir. So thank you for such a nice introduction. So good afternoon to all the participants. So let's share my screen. So yesterday I have discussed about somewhat engineering dimension T reduction, in which we have discussed about how principal component analysis and LDL linear discriminant analysis techniques can be utilized for dimension T reduction. We have also seen the purpose of these two dimension T reduction techniques, in which one we are trying to minimize the information loss. Okay, so based on the data in which the data is highly variable, that particular features or direction we try to retain. And in case of LDA, which is based on the discriminating information, how much discrimination of data is being. So today I'm moving a bit more application oriented kind of presentation, in which I'm going to talk about various robotics agents, in which and how machine learning and deep learning has changed our robotics areas. Okay, so the topic is machine learning application for robotics, and I will also discuss, if not today but in coming classes, how human activity recognition can be performed using TinyML. TinyML is compressed deep learning model which support microcontroller based computation devices, and it is also enabling us to design the edge computing techniques, which is advance of the cloud computing, in which device is self-sustainable to do the task by itself, capture data and so on. We can, so let us go and let us see the application of robotics, how machine learning has changed the way. So we'll check. So the topics which I'm going to cover is, let us first see the definition of robot. What is exactly robot? Because in artificial intelligence or machine learning, we have agents. Agent could be your software agents, your hardware agents. Okay. So many times what is happening? Agent has man duty. An agent has man responsibility to perform their task. So there is robotics agents, there is software agents, there is hardware agents. So the agents used to execute your task, because in machine learning AI, the first thing that you perceive the environment. Perceiving the environment means sense the environment through visual, through audio, through text, or whatever means. So there is sensory organ or senses by which you can perceive the environment or receive the information from it. Then you used to process in the brain. that when you used to plan on things and then you used to execute. This is what AI. Modern AI is not rule-based AI. This is connectionist AI in which you have neural networks. So in one session also I will discuss about. Then we'll see the current definition and modern definition of robots. How robotics and AI is integrated together, because world is moving toward interdisciplinary kind of areas in which various technological aspects, whether it is virtual reality, augmented reality, coming together. From the then introduction to machine learning and deep learning concepts, the concept of machine learning with the robotics application, and final I will discuss about robot or industry 4.0 standard, which is recently in underway, how robot industry is identify helping us to achieve the industry standard, which is 4.0, as we have seen that industrial revolution, information technology revolution, nowadays AI is evolving, and in future you will have more form of AI, virtual reality, robotics, and all sort of things. So how we are matching this current technology of machine learning with the 4.0. Okay. And then a few of my works with the based on the human activity recognition for the robot walking generation using different computational data-driven techniques, neural networks. Second thing, how you can draw different geometry through the deep learning or neural networks, like pedagogy, in which we can teach or the small baby to learn alphabets and something. Similar way, the robot can do the task. So for this also we'll explore the opportunity, if not today, but some other classes. So let us come on the definition of robot, which earlier definition in here. You can see the picture in the top right corner. It is the picture. It is manipulator kind of robots, which have one hand is fixed. Okay, and there is some joints angle. The joint could be revolute joints, which used to rotate. There is two kind of joints. One is a revolute joint, around which we used to rotate. Another is prismatic joints or hinge joints, in which we used to slide over one another. Okay. So generally, most of the robots have revolute joints. The importance of revolute joint is help us to achieve the the definition of robot is given by the American Robot Institute of America. Initially, they told any machine made by human being. So this is not true. The machine made by human being is not robot. If AI enabled, so we require some capability in which machine can think or plan the similar way human being used to do some optimality. As machine learning, the object is to optimize particular function to get the maximum approach ingredient. Second thing, that the purpose of robot to solve or make the human life easy, to solve certain tasks which human find very difficult, we can solve through the robots. But it doesn't mean that every machine which is designed by the human being is robot has standard definition. It has at least required 3 degrees of freedom. So these joints are provide us degree of freedom. If you want to rotate your hand, you can go up and down and left and right. This kind of motion is possible only due to the joints. You have joints which allow you to move here and there. Okay. If you have hip joints, you can rotate, you can go left and right, you can move front. This we call hip flexion and abduction. So there is certain degree of movements, degree of freedom. We used to refer this term as degree of freedom. As human hand is total 5 degrees of freedom. Each hand is 10 degrees of freedom total. Neck has 1 degree, 2 degrees of freedom. So total human body is 25 degrees of freedom. It's consistent. So later on, they have modified the definition of robot. A robot is reprogrammed. When you have heard about embedded devices, in which you have whether washing machine or something, they have some preset of software programs which they use to execute. So it is not reprogramming. You cannot change the functionality. Something you cannot learn through the data. And machine learning, what we are doing, we are trying continuously learn through the data. Our behavior is updating, our belief and hypothesis is going to update with respect. So that's why a robot is a reprogrammable, which you can reprogram multifunction. Same robot can utilize for different sort of applications, like suppose for some sense it can be utilized for multi-utility. This is manipulator robots, which one end is fixed, and you have seen that most of the time in assembly line, car manufacturing nowadays for painting, somewhere people are using these kind of manipulators, and it helps us to move one material from one place to another. So robot is a reprogrammable, multifunctioning manipulator which is designed to solve or perform the task or move the material, some parts, tool, or specialized device through the variable program motion for the performance of variety of tasks. There is no particular set of tasks. We have a set of tasks which you have to perform. Same Robot Institute of America has redefined this definition and they have proposed in 1970. Robot is exactly Jack words which mean the work or worker or servant. Mostly it is assistive device which help us to human being to perform the task to reduce our burdens. So generally, robots are supposed to work in the some environments which is we call dull, dirty, and then dangerous environment. But before ML and after ML, what changes we have seen in robotics industry that we can change. Robot without ML, that means they have not any computing power which can learn through the data you can acquire through the sensors, camera sensors, pressure sensor, different sort of sensors. You can see that traditional manipulator robots, which has one end is fixed. Okay, so there is no variable programs they use to perform certain tasks without AI and something. Nowadays we have manipulator with have camera sensors. They have different collision avoidance techniques or diagnosis system. Another category of robot is lag and wheel robots. So different sort of application is robots. Some robots are very similar to human being. We used to refer as humanoid robots or bipedal robots. And the basic utility that they are supposed to work in the human similar environment. They are supposed to play like human beings soccer games. Okay, they are supposed to play or entertain human environments. And the utilities at the extent the humanoid robots they can work in such a environment where uh, mobile robots or wheel robots are difficult to walk, uneven terrains like in fields and other places where the terrain are not very flat. There humanoid robot can walk because human walk is very energy efficient. So we can utilize the bipedal and humanoid. The lagged and wheel robot is especially used for to space exploration, and you can go send them in space when some space kind of activity you are exploring, some unmanned site where human being cannot reach or finding difficult. These things. Then you have autonomous and unmanned robots, include underwater robots as well as other things. The NLP session will take some other times, okay? Some other classes. So now a traditional use of robots, you will find that robot used to work in the 4D environments. That is called dull, dirty, dangerous. Here I am trying to teach you or inculcate how robot industry has changed after introducing the machine learning and AI and how they are able to match with the industry 4.0 standard. So dull task means repetitive, boring tasks. The repetitive jobs that are boring and stressful for human being that you can perform by the robots. Like you can see that in an assembly line or boards, just you are picking and placing the board over this moving surface. You have seen in airport also when your luggage is going to be devote that time, you can see that they are placing your luggage over there. So you can deploy such kind of robot to perform this task from that chair. Okay, another is manual task and dirty tasks, dull, dangerous, dirty, and difficult tasks. I will talk like cleaning of wash basin, clean of toilets, and other things, which human will find quite dangerous as well as difficult in sense of dangerous, uh, because these are not hygienic. So manual tasks that human don't want to perform, so that you can perform by the robots. Another sort of application is that like firefighters, at that time it is very difficult if a human being will do this task, that it can lead for the casualty and loss of human being. In such case, you can go for autonomous uh, as extinguisher. Okay, so dog of dangerous programming, bomb disposal kind of tests, space exploration, all sort of things you can perform or deploy weather. If you are sending on the Mars mission, that time also you can send such a autonomous vehicles also. Now let us see the difference how AI and machine learning has changed our way of working toward the robotic industry. Are the robots AI enabled? The question is coming first. Are the robots really intelligent? If they are, what is intelligence? What robot can do, and what is required for this? Answer: a robot is as smart as it's initially programmed. But there is controller, and controller is nothing but it is program which is executed over your computer system or running their software programs. Okay, so that kind of functionality can be performed by robots. Cannot we do any task which is not programmed over there? So the answer is robot is only that much smart. We have human being have emotion quotient. We have human being have decision making capability in the certain amount. Now the question is coming: what is artificial intelligence? What is intelligence? Is the behavior performed by the human being in unknown or difficult environments that we call intelligence, intelligent behavior human being use to perform. Artificial intelligence, some agents which are not real human being, which is agent which is used to mimic the human kind of behavior, whether it is walking, thinking, solving problem, and all sort of things. The power of machine to copy intelligent human being. So if you see the Kismat robots here, you find the image of Kismat robots. That was the first robots which is considered AI-enabled robot. This one. It used to perform some kind of emotion also. If you are weeping, it will reply back. Such some Japan has also some different category of robots, which is somewhat considered as the AI-enabled robots. So the AI-enabled robots will categorize only once they will have the capability to copy the behavior of human. Now, what is modern robot, and what could be the robot structure after 10 years from now? So even now, it is very difficult, still not common opinion about the definition of robots, about the experts. Easy task come to agreement on just what robot is and what is not. Even robot system is finding very difficult to come with a common agreement on. So, new and simple definition: robotics is where AI meet the real world problems. So, robot is a reprogrammable and multifunctioning device which used to perform the task for human being with a certain 3 or more degree of freedoms. At least you require 3 degrees of freedoms to move the task. So most of the current robots are designed the range of behaviors. Okay. How about the robot or humanoid robot from now 10 years? So it is quite optimistic. A robot will like humanize, they are sleeping, they are thinking capability, they are fully enabled with the like brain control functions. They will have neural system to simulate and all. So challenge for AI and robots. Challenge which AI used to did and robot industry for. In AI, we used to program to think, to mimic the behavior, to perform in the unknown environment. Like you have problem solving approach in AI, where you have different searching technique, depth first search, breadth first search, A star or uninformed, informed search we were used to solve or the some puzzles or some path planning or some sorting of things. So the objectives in AI is program to think. We require social interaction, emotion recognition, gestures, and we require the capability where we can learn through the external world data and then mimic or perform external. Wherein in robotics, we require to do particular actions, we require program to do. So each and everything, we are not learning anything like in AI. In robotics, we are writing the program, whatever program we write, that much only that should. There's very less level of social interaction. They are not interacting like human being used to interact with one each other. And only as smart as programs. So let us define the AI or machine learning. AI used to describe the machine that mimic the cognitive or especially brain function, brain capabilities, or you can see that neural capabilities of human minds, such as learning and problem solving. Problem solving is further classified as configuration based or configuration where we don't know the code, we just know the behavior of goods. We try to find an entire search space or state space, and we try to reach that code. Whereas another is that path solving problem in which we used to find the optimal path or search problem. So you can represent entire problem as a state spaces where each state is one problem, and thus moving from one state to another or searching the solution is called finding the solution. The traditional problem or goal of AI research was include reasoning. As human being, we used to mimic or perform different sort of actions. We never directly accept anything as it is. We used to reason whether it is positive or negative, whether it is correct or wrong. Okay, whether if two players are playing chess games, so our move will depend on the our opponent moves. There is single agent where single person is playing or single machine is playing. There is multiple agent. There is group agent where, like in soccer or football match, multiple people are doing. Individual action will not help. Your action should be coordinated according to entire group. Okay? So you require planning, learning, NLP, which someone has written, natural language processing. That is quite. I mean, almost people have solved many of the things like sentiment analysis, speech recognition, text writing, other sort of application in there. Though this is quite challenging compared to the programming language. In programming language, you have this fixed set of vocabularies, but in natural language, we are getting with different phonetic essence, different multiple words and multiple meanings. So some challenges you are dealing, which is present in the real world language. Apart from their perception, perceived through the environment, through sensory organ, and ability to meet the objects. That is what the traditional goal of AI was defined. So, if you see that in this diagram, and maybe you have seen before also, artificial intelligence is the bigger set, compared with the ability to read human, reason like a human being, think like that. Whereas machine learning is the data-driven techniques in which we are comparing with the ability to learn without being explicitly programmed. We are not having preset of program like we have depth first search, breadth first search, or bubble sorts, or some techniques where you define the preset of records and it will sort it out. In this case, we are automatically learning from outside through the data. As more data is coming, we are learning more and more. Then we are coming on deep learning and artificial neural networks. These are the new set of things. in which we have hierarchical structure. As I need to remember particular face or image, so I need to go by hierarchy. In machine learning, we need to provide handcrafted features, then only it will work. But in this case, we have network, where in the network we try to learn the better features, okay, in deep learning. So what I mean, machine learning is a type of artificial intelligence, subset of artificial intelligence that give the ability to machine to learn things through the training data. That's why we tell this is data intensive, data driven techniques without being explicitly programmed. We are not training before, we will train after. Once you have the data, and the way you have data, then the data only help us to learn them. In essence, these types of program can teach themselves and grow when they given the new data to work. In this case, what is happening? They are having data, and based on data, you are learning the task. Suppose you are preparing taxation systems or healthcare modules, that time you require such category of data. The learning system involves like things. First, you require the data, and data should have pattern. Without pattern, you cannot repeat or mimic something. Okay. So a basic attribute of people categorization of sensory input. Whatever sensory input are coming, the human has this sense. We used to categorize whether it is human being, animal, based on input data. So, okay, you have patterns. Based on pattern classification system, we used to classify the data. So, example of pattern recognition task. Some example which robot also used to perform. That time you can do. First, reading facial expression, smiley and neutral, such kind of expression you can read by the seeing the facial expression. For this, you need to provide the features related to face, different sort of. Recognize the speech, what particular person is saying. Okay, this is the things. Third one is that reading. Document require reading skills. You have to read the data, you have to classify the data, you have to text it. Third one is identify person by the fingerprints. So like you have different biometric things, whether it is gate-based biometrics or this one, you throw the fingerprint together them. Third is diagnosis from the medical images. Okay, so like yesterday I give an example of the cancer detection, whether it is malignant or benign. So based on this one, you can diagnose whether patient is mild affected or something, and then wine testing or some other testing. So from patterns, we try to extract the features. I explained yesterday feature selection and feature extraction. So you can understand what is feature extractor. Once we have extracted the feature, and based on this feature, you will train the classifier. Okay, classifier will help us to classify in a similar way as human being used to categorize the task. So feature extractor makes some measurement on input pattern, and X is called feature vectors, which has n dimension feature vectors. Then there is coming in supervised learning, in which we have already supervised the data. The classifier map is feature vector to associated class level, okay, or category, associated categories. Then feature to be used for problem space. Your feature is there. So now I'm taking simple example of some fish. There's two category of fish. One is salmon, another is sea bass. So which category of fish is there? First, we have images. We have scanned through the camera or somewhere. So we have pre-processed. We have removed background subtraction, some noise removals. Noise is also important property, but sometimes we used to remove. Then we'll extract feature from these images. Based on features, we have done some machine learning classifier. Then we'll classify category whether it is salmon and seaweed. And how good your model has done, it depend on that how perfectly you are able to identify the true value as well as calculated value. So very basic application of machine learning are optical character recognition (OCR). You have seen also MNST digit recognition data, handwriting short letter by the postal codes, input device for PDS. So in post office, people are scanning your letters. They should able to scan your writing text. Printed text reading machine from blind people. Nowadays, in flights or other where you can find in aeroplanes, there is instruction you are getting in the braille piece. The person can read digitalize text documents. The biometrics, various biometrics kind of things are there. Face recognition, the robot can identify a person. The verification of person, whether person is correct or not. That's due to the pandemic of COVID. Now it is become feasible. People are opening now online bank account. The bank operation you can perform online transaction, but opening was quite difficult. But I see that now bank is just asking some online meetings. They are asking just show your PAN card, voter ID card, and all sort of things with the biometric identification scanning there, and they are able to open within a 1 hour your accounts online. Many times, always pandemic is coming as a blessing also. We have our infrastructure drastically changed as COVID-19 arises. It has changed. Almost every education is now online, and that is the best way. And it was maybe we used to take almost 20-30 years to replace this one, which we have done or adopted within a year. So that kind of fingerprint. Then diagnosis system now, teleoperation, telemedicine. Doctor is also available online, so no need to visit an unnecessary wait for long queues. You're getting appointment, just come online, just show them reports, they will like it. So you can see the changes. These are small changes, but technology always enabling, technology always making our work less. So never discourage technology, always appreciate technology. In any sense, it is coming, though it has some drawbacks, also some dark area, but technology one must have to adapt. Medical diagnosis, X-ray, ECG, EEG analysis, many more machine learning model is there, which is as accurate, maybe far better accurate than human being. If there is no report, we don't guess, but then the doctor able to identify whether the person is suffering with something. We require medical diagnosis. Military application. Advanced sort of missiles are getting. You can get missile. They are very accurate targeting the snipers. We have seen that in which you can go and match with this one. Automated target recognition. They used to recognize in the crowded area where they have to target the person or things. Image segmentation analysis recognize from the aerial or satellite photo, identify the location where terrorist is there, where is the opponent or the people are there. This we can do. Then more application of AI and ML, you can see that understanding the human speech, whatever we are speaking, because we have different accents, some are having different accents, so it is finding language translation, one language to another, translate English to Hindi or English to Marathi and some other. Game planning, like strategic game planning, chess, twin problem, other problems. We have football also. We have group players, multiple brands are, the driverless car. You can see that that is semi-automated system. We are nowadays modern, like I've seen that Mahindra XUV7 and other, they have land following capabilities. Many advanced robots they have. They can use almost. They are moving toward autonomous car. Okay, natural language processing already discussed. Neuro marketing through BCI, brain computer interface, in which whatever you are planning, you can control certain things. You can control your hand and other artificial assistive device. Google route through routes through the Google Map, inspecting fruits, vegetable quality. If you are supplying vegetable from Kashmir to Kanyakumari, how much rate it can sustain, is there any possibility of getting damage or something? We can easily segment, we can identify the fruit, inspect the fruit by the image processing techniques, categorize whether this fruit will sustain for 4 years, 5 years, chatbot, and we are nowadays you can see an ICC bank where chatbot is already there, in which they are automatically communicating. Their call center people are automated, yet supporting us. Now landing toward AI-based robots. The current and future ML application in robotics, how far it is taking us, what is that? So machine learning in robotics, how much it is integrating. So one is computer vision or machine vision. So that I hope that everyone has heard about machine vision and computer visions. You have cameras, different sensors, imitation learning like copying of some behavior, imitate the behavior. Okay, like yoga posture and other activities they are using for rehabilitation purpose or assistive. Self-supervised learning, assistive and medical technology, agriculture role, and surgical role. So this is the span where now machine learning has enabled the robotics industry to grow by this sense. So computer vision and machine vision. And this is practical about railway station and airport everywhere. There are some manipulator which has camera which can pick the dust or garbage and they can place over the different tag like paper, plastic, and metal. So they require basis object recognition techniques. Based on the category, they are applying such force so that it is very delicate, so it should be cared very carefully so that you can place over the different dustbin. So they are categorizing based on their categories of objects. They are recognizing the objects, categorizing them, picking them based on their requirements, and then dumping on particular garbage collectors. So application are identifying and sorting the objects. You have heard about the YOLO networks, very popular YOLO networks, which used to apply for almost more than somewhat 100 objects. The vision guided robots and now assembly lines. And then we are matching with the industry 4 revolution. Moving into the next industry revolution 4. Machine vision facing a new area. You have seen that automation of car plants, where the automated assembly line is there. Somewhere you are placing your tire, chassis, bodies, painting, cleaning, dusting, all sort of things is done by the robots, and these are very sophisticated robots. They are not harming the body, even though it is possible that if human being will do, they will definitely going to dent on your car and somewhere. Let us do by autonomous systems. They are passing through assembly, they are checking, they are all diagnosis systems. And you assume that nowadays, hardly we are taking 10 to 15 days, we are getting our car delivered at remote location also. So with the introduction of simple and more sophisticated robotics platform, the ability to see as part of automation, automated production, which reach a level not seen before. Okay. Nowadays, each month the car they are selling different Hyundai, Tata, Maruti, they are selling more than 50,000 cars in a month. Different. The imitation-based learning where we are trying to learn some dancing practice, some behavior we are going to see. It is like observational learning. A baby has to learn to ride, dance, or feeding, and some other way. A behavior exhibit by the infant or toddlers is coming in these categories. You pick the whatever action you will perform, the robot will also perform. Okay. Am I audible? Someone is writing. Varun, the voice is not audible, is it? Am I audible, sir? Maybe someone else is listening. Maybe is there some problem. If I am audible, I will continue.
Yes, sir, you are audible.
Okay, perfect. Thanks. Thank you. Okay, so when I'm like you see that in house when people are staying, elderly people are staying quite alone, they are there. So many times what is happening, they have to perform, they need some help, assistive kind of things. So they require water. So they will perform some question. Robot will imitate or learn the way and will perform the task. Okay. For this, we require very much stability of the model. But the robot are not stable. That's why you have not seen the outside laboratory custom human because they have not designed as human being. Human design of autonomy is very perfect. They have designed in such a way so that they can work in unknown environments, uneven surveys, this kind of balancing of body pressure and all sort of things is required because there is physical force, ground action force. Then self-supervised learning. Many times we have not trained with something and we are learning, we are partially trained. Suppose we have to identify the obstacle is coming in my way. There is infrared sensors, they will identify the obstacle which is coming in your way, or either you have vision-based camera in which you are scanning these images, and different sort of category of vehicles are there. All category of vehicles is not used for 10, only few are used. So in self-supervised learning approach, it enables the robot to generate its own training example. Maybe we have example of Innova car and some other, but some different categories vehicle is happening. But in principle, they have wheels, they have some structure and other things. We can categorize. This is category of vehicles, so I need to stop in front of them. Then only my sensor will. There is. You can see that now parking sensor is there. They are alarming, give you alarm. They are guiding also the direction and also. So many improvement has done. They have their label to certain level. They are identified. They are providing the image of by the parking sensors. Similarly, they have different sort of sensors. They have assistive devices. They have land following capabilities. Okay, land assistive obstacle detected. If speed is increasing particular limits, they can stop. If during driving you are sleeping, so they will observe your mental status, and if you have slept, they will give you warning or either stop your car immediately. Okay, automatical braking system, ADAS system is also there. Okay, which I found in MG Actor and other. They have this ADAS kind of system, very advanced AI enabled cars. Then autonomous vehicles are the robot with self-supervised learning. This is the example of it, in which we have different sort of sensors, infrared sensors, they are sending sensors, they are continuously sending in the 360-degree, all fours, 360-degree sensors, so that you can identify all directions. If any object is coming, it will automatically stop. It can identify the bicycle, person, everything. Okay, they are also segmenting identifying the objects categories, whether it is human being, whether it is car or some moving object, some dog, and some stray things are coming. Okay, they are creating like as you have seen that recently they have encountered in Bangalore. Two flight was almost about to crash with each other in the aerospace because they have sensors, but they have immediately sense. They have particular range infrared sensors or through radar, they can communicate them. You are going to in the boundary of someone else. So already there is some sensors which help us to identify the obstacle is coming in my path. Then assistive and medical technology, which is future and which is much needed domain where people has to invest much. Then assistive robots which help the elderly subjects, physically challenged person, and the person with the disabilities or different capabilities. Suppose person has lost his leg in accident or some way they are paralyzed or something. In this case, we can do some sort of training, exoskeleton we can design with the help of this training. The robot will able to walk or try to regain this own walking patterns because some behavior is neural system related behavior. If you are walking can be affected due to the decaying of neural systems. As you will grow, you will find difficult to walk over, climb and down stairs. Your neural system will become. Due to this, you will lose certain motion capabilities. Okay. So in this case, you require some rehabilitation or some assistive device by which you can regain your behavior. So assisted obesity is a device that can sense and process sensory, whether brain control also. Suppose a person is unable to speak, will place some neurosky kind of channel recording system over the person brains and will read the signal whatever is coming from their end, and then will ask for them and perform the action and benefit of people with the disability. We can serve them waters. Now in the hospitality industry, the robot is also quite popular in the restaurant and other places and airports. During COVID, it is very dangerous to diagnose the COVID people. So let us perform these tasks by the robots, deploy the robots. They can collect your samples and other things. Same example in assistives. So you see that in Japan is the country where the maximum people are elderly people. They are finding quite difficult to get entertained. So robot also helping to entertain, play like their grandchildren and other things. They can assist. They can manage to walks. They can perform the dance for them. They can perform the singing also. Them recording. Apart from them, they help us to perform the task which is we can do in the homes like cleaning, dusting, other sort of tasks we can ask to perform them. Now coming on the last and but very important application is agriculture robots, which has almost covered the section. And you see that these are the wheel robots. Why wheel robots? Because the surface or the area in the fields are not flat. They are uneven. There is a possibility of getting some hole and other things. In this case, we can deploy some mobile or wheel robots there, which can walk over their agriculture farms. They help us to harvesting and blowing the things deployed for agriculture purpose and generally used for harvesting purpose. So these are wheel robots. In agriculture, they are especially using for and these are the emerging applications in agriculture. This is the demand in India also as per industry 4.0, and government has investing too much in this domain for agriculture, like weed control, in which you used to put the medicine over the long areas of your fields, like you can have the tea fields, tea bagan, where you can spray these kind of medicine so that insects and other can die through the help of drone and other devices, because these land are quite long. You cannot go there. Cloud seeding. Nowadays, seed is kept inside of some bowl in which you will put the seeds, and with some fertilizer is also added, and then they are throwing on the ground with the help of aeroplane or helicopter somewhere. Planting. The robots are also using for cutting the small tree and for beautification of the campus and other harvesting purpose, picking and pulling the elements or fruits from there. Environment monitoring, which is continuously monitoring the your fertility levels, soil standards, whether soil is getting wet, you require the humidity levels, you can check. Various sensors are there to measure these things. These are the areas which are the emerging application. With the help of machine learning, robot can perform these tasks, and that was the quite optimistic. Now moving from industry regulation 1 to 4, and how much we have achieved and where we are finding our robotics industry has that is span or not. So we see that industry 1 standard, which is in which started around 1784. That is called mechanization, steam power engine, railway engine was started. Waving loans, but we were not able to get much needed success in industry 1. Then industry 2, when mass production, assembly line, and electrifying energy around 80-70 happened. This also. The industry 3 standard started in 1970 around. Automation, the computer and electronics device was getting popular. Nowadays, miniature of computer and the small device microcontroller is coming. The very small chips they are able to do. And today we are in the era of Industry 4 standard, where we are looking for AI solutions, machine learning solution, IoT solution, smart factory, autonomous factory system, cyber physical system, all sort of things. So your solution should meet, the government is focusing to meet with these solutions so that your solution will meet with the Industry 4. The robot in Industry 4, where you can found your position. The Industry 4 deals with the robotics, autonomous, automation, artificial intelligence, and many more. So you require the augmented reality. Now during COVID, the physical lab was impossible. So virtual labs, virtual kits are there in which you can perform the chemistry experiment, physics experiments. The Internet of Things is area where the things can happen on internets with the microcontroller or small devices, cyber securities, cloud where you can perform the high computation. Those sending data over cloud and getting data from there is a bit time consuming. But you can do big data analytics with a variety of data will perform simulation of your uh, models. Okay, additive manufacturing, 3D printings. So the main aim of robotics and Industry 4 is to improve productivity, quality of input, high quality products at a low price, then meet consumer expectation as demand is growing, we need to meet. So more application of modern robot industry for manufacturing. We want to quality product more and more in the less amount of time. So we can go for manufacturing of items, packagings where we have to pack the vegetable or some other things or foods, grain and other things. And there you can apply assembly line in Amazon also has opened this um, platform for this purpose. Amazon they are deployed as a robot. Military and public safety for different safety aspects also can be performed by robots. Supermarket and mall, where automatically no need of requirement of human automatically you go with the help of barcode and other devices, you can um, select the product. Based on this one, the price will automatically detect from your account. No need to pay any cash and other anything. In mining is the dangerous where harmful gases are always coming and it is something the human life many times is leading to every casualty. If you see that in the Dhanbad and other place, some coal mining which is quite dangerous for human beings. From certain year they are continuously burning. In this case, it can help. 3D printing and the furnitures you can design and you can meet the industry standard or market need. Some medical assistant application I'm going to give you. In this, what is happening? Like brain device based things. So some of my colleague has worked on this one. They have brain control device ECG recorders. So this study helped the disabled people is their life by the thought be access of light. Whatever is their brain is coming, whether we want to access light, pen, mobile, we want to open door and close. So this kind of application you can do because we are accessing the data through or capturing data through the sensor. Okay, then we are pre-processing. Then we have classified based on this category and then particular action was performed.
Vijay sir, your voice is not coming. Vijay sir. Dr. Vijay? Dr. Vijay? Participant, wait. Dear participant, please wait for some time. Dear participant, please wait for some time as sir is joining again. I think there is some network issue at their end. There is one information that I have sent the attendance link. I have sent the feedback form also for today's session. Please fill that feedback form. Okay, please fill the feedback form. Okay. Wait for some time, okay, until unless sir is joining. Okay, lecture is already over. Okay, but we want some question from your end. Okay. Participant, if you have any query, you can write in chat box also. If you have any query, participants. No queries, no query. Okay, sir has joined again. Okay, participant, if you have any query, you can ask to the sir. Okay, if you have any query, you can ask to sir. Dr. Vijay, unmute. Unmute yourself, Dr. Vijay.
If any questions, please feel free to ask. And sorry for the disturbance.
It's okay, sir. Anybody have any kind of query they can ask? Any query, participants?
Yes. Sir, good evening.
Yeah.
Yeah, please.
Sir,
Good evening. Please ask.
basic question. Sir, from yesterday onwards, we are hearing machine learning, deep learning, ANN, CNN. But here we only feed the input data, output data, and also algorithms like supervised and supervised reinforcement learning to the machine. Actually, what does machine do, sir? It just do our commands, our instructions as usual. In this point of view, we are calling these techniques as machine learning, deep learning, artificial intelligence, sir.
Yeah, so I will answer you a little bit clarification is required from your end. Maybe you are confused. So traditionally you have seen, you are from computer science background? Jiva?
Yeah, sir.
So you have got some sorting techniques like bubble sort, quick sort, and some sort of algorithm you have. In algorithm, we have fixed set of instructions which you use to execute over machine. You are giving particular input, you are getting outputs. Okay. So you are providing inputs like an unsorted array, you are getting out. There is fixed set of code, nothing is you can change. But in machine learning, what is happening? We have only input data and output level in supervised learning. We have data inputs and outputs. There is no as such algorithm. Machine itself is learning through the data, the behavior. As data is coming, more and more data is coming, my experience is increasing. So my model is getting more good trends. As you are visiting doctor, the doctor will ask you BP and temperature. How they used to recognize whether you are healthy and unhealthy? They used to measure your temperature, BP. If it is coming on the particular category, similar the machine used to do. They used to take your input through sensory inputs, which is referred to features. Then model, already trained model is there. Okay, the previous data is there based on as doctor has past experience. So similarly, machine has the algorithm or learning patterns which already have acquired this behavior. The moment you pass new data, it will try to find or map with some mathematical mapping. Actually, the classification is mathematical function, whether you are belonging to one class or another class. Okay. And then there is output. So you have input data, you have output level. Based on this one, you have training data, you have trained the model. Once model is trained, you will test over unknown samples. So I think that this query has answered by me. Will satisfy you.
Sir, but the algorithms are written by human, right?
No, algorithm is written by human being, but here what we are doing, here we are learning, we have only data. I will provide you Excel sheet. In Excel sheet, I'm giving you temperature BP. I'm giving you your other features. Okay. From these features, the output level is also given. Suppose you have healthy and binary classification, 2 levels, and you have different samples. Sample 1, sample 2, sample. You are providing your model these inputs. Some mathematical function is there which try to map with this output level. Okay. So let me output level. So algorithm you are not writing here, you are learning through the data and your experiences and how much data you have. If you have more variety of data, you have more experience. Okay, in supervised learning, you are doing class level. In unsupervised learning, based on their categorization, we are going to do.
Okay, okay, thank you.
Any more queries? Any more queries, participant? Okay. If you have any query, just send in a chat box or you.
Sir, how do you find the... Excuse me, sir.
Please ask.
Sir, how we find noise in an image?
Noise is also having important properties. Noise many times carrying some information. It is not that noise is always have not. Like you see that in plot, if you are plotting, some abrupt changes are coming, some things are coming. So okay, blurred image is there. So noise are based on the threshold, different noise detectors are there, denoising things are there, filter are there, by which you used to see that up to this threshold I will keep, above than this threshold it is not working. So you have to read for this denoising filters, which you used to remove the noise of this one. So many times what is happening, the image is very smooth, but suddenly you are getting the very high values because these are pixel values, which is not within that range, will consider noise. Okay, but it is not that noise is always disadvantage for us. Many times it is carrying many information, important information. So yeah.
Sir, for how we find out the threshold value for a noisy image, sir?
That you have to define which kind of image you are taking, whether satellite image, ordinary image. That application oriented things are there, and you have to see that different filters are available. Okay, so that time you will able to understand this one. Like in CNN model, you have seen that different filter you are applying. You are identifying the boundaries. Some image you are blurring, some image you are taking only center pixel values and also. So for this, you have to explore the denoising, how denoising is happening. Okay. One more question from Ruby, sir. Kindly refer the manuscript for AI agriculture purpose. So I've seen my ResearchGate account, some of the application of IoT, And healthcare, I can tell you, but in agriculture, I will tell where harvesting, fruit detection, fruit identification, disease identification is doing for agriculture using neural network.
Okay, sir. Thank you, sir.
Fine.
Okay, any more query, participants? Any more query? If you have any doubt, any query, you can ask to the sir. Sir is available now. You can send your query in chat box also. I think there is no query. Let me propose a vote of thanks to Dr. Vijay Bhaskar Saimalji. Sir, also your lecture on machine learning application for robotics and design of human activity recognition using Teeny ML it was a very great, informative, very elaborative and brainstorming lecture, sir. You have discussed a lot of things about the traditional and the old applications of robots. What are the current definitions and the modern applications of robot? What is robotics and how it is being used in artificial intelligence? You have introduced machine learning and deep learning. You have clarified different kind of concept that are used in machines. You have discussed machine learning in robotics. You have discussed a lot of examples and how the robots is being used in Industry 4.0. And you have discussed your research also. Sir, it was a very good and very nice lecture. I think our participants have they have got a lot of information and they can implement this information or the knowledge for their research purpose also. Sir, thank you so much for giving your valuable time and support to us, sir. Thank you so much.
Thank you, sir. Thank you.
And please share your PPT to us, sir, so that we can share with our participant. Okay, and please send. I think have you sent, sir, tomorrow PPT? Yesterday PPT. Have
Yesterday PPT, I think that I shared, sir. Yesterday PPT.
Okay.
Yes.
Please send the honorarium receipt also.
Sir, actually there was no attachment in the mail. That's why I was unable to.
Okay.
So
I am mailing you again, sir, today.
Okay, thank you, sir.
Okay. You just fill twicely. Okay.
Okay, sure, sir.
Thank you, sir. Thank you so much, sir. Okay, thank you. Dear participants, am I audible to all participants? You just fill the feedback form. Okay, participants, you just fill the feedback form. Yes, sir. Of today's session. Actually, there are a lot of queries that they haven't received the feedback form of yesterday. I have sent it many times in today also and given some certain time for 30 minutes also. Okay, 30 to 1 hour also, but a lot of people haven't filled their feedback form. Okay, so I have already sent the today's session feedback form. Okay, you have to fill it before 10 p.m. Okay, and as I have told you, 80% attendance is mandatory. So kindly fill the attendance as soon as I send. You know, I generally sent it in a Telegram also. I generally sent in your WebEx meeting link. I also send in online streaming also. Okay, so there is no excuse that we don't find any kind of attachment. Okay, because I generally share it on multiple platforms. Okay, so please fill the attendance twicely daily and fill the feedback form at evening. Okay, I have already communicate in a group. Okay, if you have any query, any doubt, I am online. You can ask to me now. Participant, you have any query, you can ask to me. Ruby ma'am, are you there? Because there are a lot of query are coming from your side.
Sir. Yes, sir.
Yeah, Ruby ma'am, please tell me. Any doubt?
You
No,
increase
sir,
our interval time.
no doubts. Actually, I was filling, but I think that it took more time in writing those actually 100 words.
Actually, listen, ma'am, because in feedback form we have given because we generally dispatch it at 3 p.m. and closing time is 10. Okay, I think it's a 6 hour. Okay, you can fill it easily in 6 hours, and that is maximum 100 word. Okay, no need to write everything. Okay, only get the content, whatever you have discussed with the resource person or whatever you have learned. Okay,
Yeah.
that particular session.
So yes,
Okay.
so for the yesterday feedback form, like I was filling, but I think that it took more time in writing also. So that's why I think I missed it again.
Actually, on your request, I have opened it wisely. Okay, but when time is over, I have to close it. Okay, there is because some certain rules and regulations we have to follow. Okay, to dispatch the certificate. Okay, ma'am. That is a
Okay,
foundation
sir.
on our side.
Okay, sir.
Okay.
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 Yeah.
Any more
Thank
query?
you. No, sir.
Okay, so happy
Hello,
Republic Day
sir.
in advance. Yeah, please.
Sir, Sumit here.
Yeah, Sumit, tell me.
Sir, there is a issue, sir, in your given voucher. There is the Chatterjee, Professor Chatterjee is here. But in the seminar, in the webinar, sir, the Vijay Prakash sir, Vijay Bhaskar sir here. Then, sir, what will we fit in last one? Resources?
He will be there because he is suffering from COVID. He have severe health condition. Okay.
Okay, sir. Okay. No problem, sir. Sir,
He will
then
be there at 27.
I have to mention, sir. Then I have to mention the Vijay sir in the
Yeah.
last resources.
Yeah.
Okay, sir.
I
Thank you,
have
sir.
sent the detail in Telegram group. Okay.
Okay, I got it, sir.
Okay. Any more query? So, participant, we will meet tomorrow at 10 a.m. sharply, and happy Republic Day in advance. Okay, Sudha have sent something. Sudha, you can ask to me. Okay. I missed filling morning session attendance. Okay, time is over for the morning session attendance. Okay, I cannot do anything now. Okay, because morning session attendance should be filled in morning only. Okay. I will provide 2 to 3 hours for filling the attendance for the morning session and for the evening session. Okay. I cannot give too much freedom now. Okay. Good luck for the tomorrow session and happy Republic Day in advance.
Happy
Thank you.
Republic Day, sir. Yeah.
Okay. Thank you.
Sir.
We will meet.
Thank you so much, sir.
Okay. Thank you. We will meet. We will meet morning at 9:45 a.m. sharply. Okay. And if you have any kind of query, you can call to me anytime. You can text to me anytime. Okay. I will reply definitely. Okay. Thank you.
Okay, sir.
Thank you, sir.